Hello, in this video I'm going to show you how to implement a Bayesian network using Python version 3.10 and PyAgrum library version 1.12. If you don't know what PyAgrum library is, it's a library where you can implement probabilistic graphical models. Okay, it's mostly focused on Bayesian networks, but you can also implement influence diagrams, Markov networks, Gradle networks, and probabilistic relational models. Okay, so this is the main web page of PyAgrum. I already have installed over here. So to implement that, to use as motivation or as an example, I took this example from the Book of Why by Judea Pearl. If you don't know what is the Book of Why, it's a book written by Judea Pearl, who was the inventor of Bayesian networks. Okay, it's a very interesting book. If you want to take a look at that, I'm pretty sure you're gonna like it a lot. So mainly the book, it's about causal networks, essentially Bayesian networks, since this was invented by Dr. Judea Pearl. Okay, so I took the example from the book, and this is exactly the text I got from there. The only thing that is different is those are those percentage that I put over here just to clarify, just to make clear what we are trying to do. Okay, so I'm just gonna read what is here. Out of 1 million of children, 909,000 get vaccinated and 9,900 have the reaction, and 99 die from it. Meanwhile, 10,000 don't get vaccinated, 200 get smallpox, and 40 died from the disease. So according to this data, and by the way, this data was released in Europe right after the introduction of the smallpox vaccination many years ago. And this raises kind of concern because based on this data, as we can see, more people will die from vaccination than from the disease, right? So according to this data, 99 children are going to die from the vaccination. And those who didn't take the vaccination and died, they are 40 people only. Okay, so this raises a kind of concern about if vaccination is effective or not, it's harmful or not. Okay, so the idea here is not to debate on vaccination or not, but rather to show how can we implement this thing using a Bayesian network and try to extract some information to see in reality what happens, right? So the book also showed us this graph. So this is a direct acyclic graph. The intention of this video is not to explain what a Bayesian network is or discuss the theory behind it. So to follow this video, you should know what is a Bayesian network, at least know the basic idea of Bayesian networks, okay? So this is the graph you're going to implement. And this is, again, this is from the book. This is the figure 1.7, okay? So the question that we ultimately want to answer here is vaccination beneficial or harmful, okay? Because, again, based on this data, it's harmful, okay? So again, using PyAgrum, we are going to implement that. So the first thing we need to do is to import PyAgrum using import PyAgrum as gum, okay? And since I'm implementing this thing in a Jupyter notebook, at some point we need to see the graph, right? So to make it work, we need to implement a submodule of PyAgrum library, and this is the notebook module, okay? So we only need those two imports to implement that Bayesian network, okay? I just paste it, it's running. So if everything is working as expected in your computer, you're gonna see this green over here. That means these two lines of code run as expected. Okay. So now what we're gonna do is to create the graph. Okay, so this is the first part we should know. We should do, create the graph. So I'm gonna call the GUM, which is the PyAgrum, and the method fastBN. This is a very interesting method where you can basically describe the structure of the network, like this structure over here. Okay, to simplify this implementation, I'm going to consider only the first letter of these variables. So we have 4 variables. Okay, those are going to be binary variables. That means every single variable here has only 2 expected values: true and false, yes, no. Okay. So for vaccination, I'm going to use the letter V, reaction, I'm going to use the letter R, and so on and so forth. Okay, so let's start with this side of the graph. So vaccination goes to reaction, that goes to death. So using fastBN, we can do just like that. You put the letter, okay, corresponding to, this is my assumption, correspond to my verbal, dash, the greater than symbol. Okay, so this is the greater than symbol. The font I'm using here, it has ligatures, so that's why it's hindering as an error. Okay, so but basically you need to type dash and the greater than symbol. Okay, so V goes to reaction, right? So goes to reaction, that goes to death. So V R dash greater than, and then def. Okay, so with this, we did this first part, first side of the graph. So now we need to do the other graph, other side. Okay. For this second, the right side, I'm going to start from the end to the beginning. Okay, but you can see how it's going to happen. So def is the end node over there, right? So we can use smaller than signal as we did. And then we have smallpox pointing to def. And on top of that, we have reaction vaccine pointing to smallpox. So this is the right side of the graph. Vaccination pointing to smallpox points to death. Okay, so we can use both directions arrow over here. So that's it. At least the graph for that Bayesian network we have implemented. Okay, so I'm gonna hit Shift Enter here, VS Code, just to make it run. If you type just BN, since we are using a Jupyter notebook, we expect to see the renderization of the graph. There we go. So here we have exactly the graph described in the picture, right? So this is the first part, the graph. We have 4 variables. We didn't specify any value about those variables yet, but we have at least the directions of those variables as expected. Okay.